and so they're extremely territorial, and they exclude other coyotes from those territories. And so basically it's very easy to identify what their territorial boundaries are. And so that's what we do across the Chicago landscape, is we draw these maps, and we're interested in where they occur, especially with people. How are they able to maintain these territories? The way that they defend these is rarely physical. So we've rarely documented injuries caused by other coyotes, which also separates them from, say, wolves. Wolves, if you're not shooting wolves, the primary cause of death for them are other wolves. They're extremely defensive, and they will kill each other. Coyotes, we've never had a death from coyotes injuring each other, even though their densities are extremely high. They usually defend their territories through howling. So when you hear coyotes howling, they're doing it for two reasons. One is to advertise to other coyotes around here that this is an occupied territory. And when they're howling as a group, what we have found, and we've tested this here at McGraw as well as some other places, we know that coyotes can tell, they can count how many coyotes are in that howling group. So we can try and count, and we're horrible at it, but the coyotes are actually pretty good. And so the other reason for the howling is that it brings the group together. So they are very social, even though you often see coyotes foraging by themselves. But if it's a resident animal, it's part of that group, and just like your dogs, like if you have two dogs that live together, if you separate them, and then you bring them back together, they are pretty happy, right? They do a lot of sniffing and licking. They lick all parts of their bodies and stuff like that. Coyotes do exactly the same thing. So it's really important for them. The howling is part of the glue that keeps that group together. Not all coyotes are equal. So the alpha animals will start the howling bouts, and then they'll be joined by the other members of the group, and the pups start to learn how to howl at some point during the early summer. So you may or may not be able to see these, I hope. So what we've seen is that the population has continued to grow, and you can see that spatially. So this is Poplar Creek Forest Reserve, again, just down the road. And if you can see the pink dots, at least, those are the dots of an alpha female. So she's the dominant female of that group. If you can see the blue dots, those are the dots of her son, who's a year old at that point. So he's a yearling. He's still staying with his mother. And the extent of that territory covers most of Poplar Creek. That whole western side is one pack. And that was in 2000 and 2001. If we fast forward, we go to 2002, and things start to change. And so this is a coyote soap opera taking place. So they move off. That's because unrelated coyotes moved into part of that territory. And then you'll notice that the son and the mother are separated. He became sexually mature. And so she took the north end, and he took the south end. And then he ended up living for over a decade. We followed him all the way through. And he lived his whole life in what amounts to basically 1 square mile area of Poplar Creek as an alpha male. So he found a mate. They created that little corner right there. His mother created that corner, or remained in that corner up above. And then over time, we've had more and more packs. So that, again, the population is growing. When the population grows, if the food supply allows it, and it turns out that our Cook County Forest Reserves are abundant in food, most of them, Poplar Creek especially, then what they'll do is that young will split off from their parents, and they'll create these smaller and smaller territories. So you'll see the different colors there. Each color represents an alpha animal from a different pack. So we went from 1 pack, now we have 5 packs. And 3 of these, the pink dots, the light blue, and the yellow, are all the adult offspring of what was Coyote 21, the one in the dark blue. So those are his adult offspring that all became alpha animals. And then if we continue this is what it looks like as of a couple years ago, so actually just last year. So it's filling up even more. So we have about 6 packs, 7 packs, and then if we continue, we have one of our animals that was born on the far side, actually the grandson of Coyote 21, eventually sets up a pack over here in the corner. So we have 8 to 9 packs all living in Poplar Creek, each pack having 4 to 5 coyotes. So you're looking at 40 or 50 coyotes, adult coyotes living in one forest preserve.
How many acres is Poplar?
I believe it's about 1,500 acres, I believe, or 1,800 acres. Yep.
And what's their primary food source?
The primary food source, I'll get to diet in just a second. So I gotta move on. So in addition, that's within a forest preserve, and you can see that the boundaries of those territories are all within the forest preserve. They did not go into the subdivisions. But we have other coyotes that are living completely in the subdivisions. They don't even go into the forest preserves at all. So this is just outside of Poplar. These are all alpha animals in their territories without the benefit of any forest preserve, living among people. That large pink one, that was coyote number 1 that I showed you earlier. She became an alpha animal in Schaumburg, and she lived for 12 years in Schaumburg without a conflict. And so this is how some of those animals are living. They become nocturnal, so that's an effort to avoid us. This is actually from a documentary. That's 571, a female, an adult female. And they change their activity patterns so that they come out at night, so you don't see them. And if you leave food out for them, incidentally, then they will use it. You'll see that's that cat looking out the window. And she did that for 3 years before she eventually mange got her. But and again, she didn't run into a conflict with anyone. She wasn't aggressive, and so these people will never see her, and they're going to walk right past her. In terms of their diet. So in the early parts of the study, we use standard techniques that all other studies use, which is collecting the scat, and they mark their boundaries with scat, so they're very easy to find. That's about the only thing coyotes do that's easy for the biologists. So then we collect the scat, and then we recruit some poor graduate student or some other individual that can't say no, and we take the pile of scats in the basement, we make them go through and identify everything in that scat. And so this is the typical thing that we found. So, and these are grand averages. So coyotes shift their diet over the course of the year. So these percentages will change. So in some parts of the year, like this time of year right now, rodents will make up to 80 to 90% of their diet. Then it will drop during the summer as fruit becomes available. That fruit becomes over half of their diet during certain parts of the summer, and then 0% in the winter. So these percentages are changing, but it does give you an idea. These are the big 4. And every coyote study across North America that uses this technique for diet always reports those 4 items as the top one. So it doesn't matter whether it's in the city, if it's out in the country, if it's in a wilderness area. Rodents dominate. Rabbits also are important at certain times of the year. And then whatever major ungulate is there. So for us, it's white-tailed deer. It can be mule deer somewhere else. And that's scavenging for the most part. So we're killing deer, usually hitting them, or we're wounding them. And then coyotes, if the deer is injured pretty bad, then the coyotes will go ahead and take that down. So that's the only percentage that actually doesn't vary a whole lot during the course of the year, that 22%. And then what we thought would be at the top was actually at the bottom, and this is also consistent with almost every study. At the very bottom is garbage or human food, and then domestic cat or a pet. So 2% and 1%, which indicated they weren't relying on us for food at all. And so we published that, just like every other study does, but we were never very happy about that because to be able to identify human food is actually very difficult, and you have to rely on them eating a little bit of garbage or wrapper or something to go along with it to be able to identify it. So I don't know if you've tried to identify your diet based on your scat. So if you look at real close, about the only thing that shows up is corn. So is hard. So you're going to miss really important things. So if they're eating a cheeseburger, that's not really going to show up using this technique. So we always thought, well, maybe we're underestimating that. But again, it makes for a good story, and it is largely true. Most of these coyotes are surviving even in the developed areas without relying on our food. But this isn't an accurate picture at all. I'm going to skip this, sorry. The other way that you can do this is you can look at stomach contents, but the problem with that is that you only get a snapshot of that animal at that moment in time. So this is from a single stomach of a coyote that was hit by a car, and so that's 9 rodents in that stomach. But it's a good example of how effective they are at capturing and eating rodents. But you can only look at a dead animal. So I'm trying not to show you too many data slides, but I'm going to show you this one, if you can see it. So this is what we call stable isotope analysis. And so I mentioned earlier that now we have techniques that allow us to look at the diet of an animal by looking at a single whisker. And so by taking that whisker from that animal when we capture it, we now know exactly which coyote that we're looking at. We know its sex, we know its age, we know where it lives, we know how long it survives, and we can section that whisker in even sections, and over the growth of that whisker, we can look at their diet and see if it changes over time. So a whisker represents like about a 5 to 6 month window into that coyote's diet. So, so what you have to do with this, you also have to take samples from their potential prey, and you look at their isotopes. We look at nitrogen and carbon. And so I'm not going to go into exactly how this works, but the nitrogen axis is over on the left. But we're interested in this carbon axis, the one along the bottom. That's the important one, because that's the one that separates human food from natural food. And it's because human food is all corn-based. All of your food is corn-based. Actually, almost all pet food is also corn-based. So we can actually look at pet food as well. And it turns out that corn has a different carbon signature than most of our other plants out here, our native plants, which then are incorporated into the tissues of the prey. So that's actually it worked out really well. We didn't know how it would work until we actually did this. But all I want you to notice is that if you can see these gray polygons, the natural ones, so these are the rabbits, the voles, which are mice, basically, or rodents, and the deer and squirrels are all over on the left-hand side, and then you have a few things over on the right. These are kibble, which is pet food, humans, which is that yellow circle, that's your diet, and then you have the actual pets themselves. And you can see that there's separation. That's what we needed to see. And so once we got separation, then we could look at each coyote and just analyze their whisker and see, well, where do they fall out on that? And if they fall out in one of those polygons, that represents the diet that dominated the food for that animal during that period. And we can also look at individual variation I'm not going to get into, but what you can see is that there's colored dots on that screen. There's just colored dots. Each dot represents a single coyote, and where it falls on that map is where is the type of food that dominated its diet over the course of that whisker. You'll see that most of them, and there's also a dotted line in the middle. That dotted line we've used through some statistical modeling. That's what we call the anthropogenic line. So that's where your diet is actually getting separated. So animals that fall over on the right-hand side, their diets are dominated by human food. And then the dots that fall over on the left-hand side are the coyotes that are relying primarily on native food. So again, most of the coyotes are on the left-hand side. So most of them are still living or using natural foods. But you'll notice that there's a number of coyotes that are over on the right-hand side. Now, if you compared that to that slide I showed you earlier based on scats, scats said less than 2% of their diet overall is human food. Well, now, because we can look at certain individual animals, you can see that there are some coyotes that almost have a complete human diet. In fact, I don't know if you can see it, but over in that human circle, there's a green dot there. So that's a coyote, and the green means that it came from McGraw. So it's a McGraw palette. So all the green dots. So the other thing that what we discovered that we thought was really neat was that those colors, they have the same color, they're coming from the same pack. So what we could find, or what we saw, is that there was a huge amount of individual variation of diet, even among animals living in the same territory together. So they're not all doing the same things. In fact, there's a huge amount of variation among these animals, even coming from the same parent, same pack, in terms of how they are using this landscape. So anyway, there's other things here, but I'm going to move off that. This is actually, but rodents still dominate, so even after all of that, rodents are still the dominant food. And here is an example of how successful these animals are at catching rodents. In fact, so rodents dominate their diet, especially during the winter, and even right now. So you're going to see this is one of our animals, and this was taken by one of our techs as she was tracking it that day. And I want you to notice it's going to catch a rodent. Now, it's going to be using its ears primarily. It's going to be listening for a rodent underneath the snow. You'll notice that the snow, where it's finding this rodent, is completely unbroken. So it's purely by hearing that it's finding this animal. So they're really good at that, and they're even doing that downtown. So it's pretty amazing. This was in the suburbs, but they are extremely good at finding rodents, even in some of the most inhospitable areas. So now I want to move downtown real quick. I just have a few more minutes. This has been another new thing that we've done. Again, when we began the study, there weren't reports of coyotes downtown. We didn't have any evidence of them living down there. We thought, that's too extreme. There's no habitat for them. They can't live down there. They proved us wrong. They proved us wrong pretty much all the time. So what we're talking about now is the urban core. In urban studies of wildlife rarely work in what we call the urban core. It's hard. And there's usually not much wildlife there. So you can kind of see this is an aerial image of Chicago, and you can see as you move from left to right, you can see that the amount of congestion, the amount of urban development increases dramatically. That's an aerial image during the day. This is an aerial image at night. And so if you look at just the night lights, you can kind of see what I'm talking about with the urban core. You can see where it's almost completely lit. There's almost no black spots. So just imagine, so that means there's very little habitat for these coyotes to live down there. And so that's where we went, and that's what we're doing right now. So we're actually interested in the area that's encompassed within that yellow dotted line. And this has been extremely difficult to do, but it's taken years to be able to get enough of a sample that we're finally there. This is an example in 1 year. These are territories of GPS-collared animals. You'll notice that some are concentrated up in the northwest suburbs. That's, again, where we do most of our work. But you'll also see that there's some that are within that core. That's a road map, a road density map. So you can see that the roads get it gets really gray. It's because it's really developed, including downtown. So those are all basically downtown territories to the right. And most of them are large. So one of the concessions that coyotes have to make when they move into a concrete area is that they have to cover larger areas to be able to get enough food, if they're not just being fed by people. But one exception is this one. So this is 740. I caught him in a cemetery. That's the Rose Hill Cemetery on the north side of Chicago. That was in 2013. And so that's him. He was this huge, he was the second largest animal we've ever caught, and a really amazing specimen of a coyote. But he had the smallest territory. So we put this, when we caught him, I thought, well, we're going to get this great map of his locations across the city. We're going to get all kinds of neat data from this animal and how it moves, through the loop and things like that. So we put a very expensive GPS collar that cost us thousands and thousands of dollars. Not only the collar, but we have to pay for the data. So it turns out that during the course of a year that he was collared, he never left the cemetery. So that's what you're looking at there. That's the cemetery. That's thousands and thousands of dollars right there. And that is the smallest territory that's been documented for a adult animal over, and in fact he's still there. In fact Shane just saw him the other day. And then what's funny, so the reason why it's small is that there are two little old ladies that are feeding him. They're feeding him, and they pretty much adopted him. They named him, they thought he was a female. So we found out from them that they named him Wilma. His name is Wilma. But that's what they can do if they're being fed. So they will restrict their range, and he doesn't go any farther than he absolutely has to.
What do they feed him?
They feed him some dog food, hard dog food, but they'll supplement it with bologna and some chicken quite a bit, things like that.
How big was he? What is
He was about 45 pounds. He was up to about 47. He's thinner now. So this is a critter cam of this isn't actually Wilma. This is his pack mate. So you see the snout, so you see the animal sniffing down. And so this cemetery told us when we asked permission to be able to trap the coyotes there, they said, well, okay, but we don't feed, there's no feeding going on in here, so they're probably not staying in the cemetery. And then this is what we found. So this is what so there's all these signs up everywhere around the cemetery, don't feed the wildlife. And that's him getting fed. So
What's their average weight?
what's that?
What's their average weight of them?
Their average weight is 33 pounds. The males are a little bit heavier than the females. So that's Wilma, that's 740. I'm going to show you 748. Now this was an animal that we've GPS collared and did live downtown. And so you'll notice we're talking about Lakeshore Drive. So he was living on Lakeshore Drive. This is 748. And you'll notice there's, you can see Soldier Field and some other things. And he's just south of the pier. And he was an alpha male. He had a mate. And they had a litter. And their litter was raised on top of a parking garage. So this is across the street from Soldier Field. And you'll notice that there's some trees along there. And so that makes it look like the parking area is on the ground, but it's not. So that's green architecture. So the top level of some of the parking garages or other areas that have a large amount of concrete have a double layer. They put soil in there and then leave openings to be able to plant the trees. So they can cut down on the amount of heat that's being reflected from the concrete. But when you create these openings and this gap filled with soil for the trees, you're also providing an opportunity for coyotes to have a den in concrete. And so that's what they did. So that was 748. And then his litter was, he was actually, the reason why he was out that day, that's actually April with snow, but he was tending the litter. So the female was in the den. Males don't go into the den. So the only animal that actually goes into the den is the mother, but he tended the den, protected it, and supplemented her. So these colored dots are just other downtown animals. And the main thing I wanted to point out is that remember at the beginning, I showed you the distribution of points of an alpha animal within their territory in an area with natural habitat. And they were using their dots was evenly spread within their territory. Well, what we found is that as they move into the city, they can't use their territory that way because of our development. So their movements become very linear. So they're using the same travel lanes that we use. They're using railroads. They're using some of the highways that go through there because there's an easement. And that easement is actually incredible habitat for them. So they hunt rodents. So this is a close-up view of some of those animals on the south side of Chicago.
How's their diet compared to the more, the urban diet versus the rural diet?
I think I have a slide of that.
Okay.
So someone's awake. That's good.
So it looks like there was a path along the sanitary.
Mm-hmm. And so this is what it looks like during the day, using, if this works. Oh, it doesn't have it, I'm sorry. This would have been an animal using that railroad during the day, but it doesn't look like it's. Here's an animal, we'll see if this works. And so they actually, shoot, I don't think it is, sorry. That would have been, there's actually an animal, they hide underneath the train cars. So there's actually an animal underneath those train cars. It's actually a great area to escape us, because humans are not generally allowed on those rail lines. This should be, let's see. Okay, this is what it looks like at night downtown. So they have to use the sidewalks and the roads just like we do. So this was one of our first downtown animals, a female. And so you're gonna see her cross the road in front of us here. And this is gonna be one of the more residential areas. It's on the north side of Chicago. And so she's gonna cross the road in front of us. And because there's not much traffic, it's just a normal crossing, and it's not very exciting and not very impressive. So there she goes. Okay, so now we're gonna show, she'll be crossing a busier road. Where this is, we're getting over toward Lakeshore Drive. So she's gonna cross here, she's gonna go over to the sidewalk as she approaches that busy road. And I don't know if you can make it out, but she's gonna start turning her head to the left right now. So she's looking in the direction of the oncoming traffic. And she recognized that there was a gap in the cars immediately. She did not hesitate, and she darted across. All right, so, and this is something that she does all the time. So that was that particular road. This is gonna be the same coyote now, a different situation. So here, she's gonna cross an intersection with lights. And what you're gonna see, I'll just prep it, so you're gonna see a guy on a bike riding past us, we're in the truck, with this antenna, so he's staring at us, and behind him is gonna be her. And what she's doing, she's sitting there watching the traffic, and she's waiting for the light to change. So here comes the cyclist, he's staring at us, and then right behind him is her. And she's been standing there watching the traffic until it stopped at the red light. So it's the same coyote, but using different strategies, crossing different roads within her territory. And she was living in that area for at least 5 years before we lost track of her. And so, an alpha female, she was raising litters. You'll see people in the back there. Those people will never see her. They won't see her coming up. So you asked about that, so we go back to the stable isotopes. This is what I showed you earlier. And so the question is for us, now if we replace those animals from the suburbs and we looked at just the downtown animals, or the animals in that urban core, we would have predicted that because of the lack of habitat, most of the coyotes should be over on that right-hand side. Shouldn't be very many on the left-hand side. And this is what we found, is this. So the red dots are individual coyotes. The dotted line is still the same, or now it's a red line. That's the anthropogenic line. And you'll notice that it looks very similar to the map you just saw, which is most of the coyotes are actually eating natural food. But you have some that are relying pretty heavily on human food. So it's a mix. They're all doing different things. And in fact, I showed you 2 of them. So this is a good test. 740 was Wilma. And look at where that dot fell. So it's a good correspondence between our stable isotopes and what we're seeing in the field. And then 748 was the one in Soldier Field. And he's clear over there. And in fact, that's exactly what we saw in the field as well, was that rabbits, there's a huge rabbit abundance around Soldier Field. And so his diet is almost completely native prey. So the mix. And that's him. Also, the thing that we're curious about, obviously there are conflicts between coyotes and people, and this is through 2011. We can go ahead and increase that to 2017. Actually, less than 5% of those urban animals ever generate a complaint or any kind of conflict. So the majority of them, over 95%, are not causing problems. There were a few that did and became dog aggressive, but just a handful, or less than a handful. And then finally, I'm going to skip the parasite stuff if you don't mind, because I'm running long. But that is what's paying for most of this work. Heartworm, they have about almost half of all coyotes are infected with heartworm. And that's unique to an urban area. And then mange is the only disease that has actually any kind of impact. The heartworm doesn't impact the coyotes that we can detect. Mange does. And so mange is a mite that burrows into the skin. The scratching causes the hair loss, so that's one of our collared animals there. And I'll just say this is another plug for long-term studies. If you're curious about what kind of impact diseases have on wildlife populations, or if you are curious about the dynamics of wildlife populations, like what could be controlling them or increasing them, you have to do multi-year studies. And so these are years, and that black line at the bottom, that's the percentage of animals that were infected with mange. And you'll see that we began the study with 0, and then mange entered the population, probably from red foxes, and then it has stayed pretty much at a fairly regular low level. That is not how mange works in the natural or the wild environment. There, it's actually a regulator, and especially it's density dependent. We thought for sure, because of our densities, we should have a huge mange outbreak, and it should drop the numbers down, but we didn't. And so now, it's just part of their population. So about 8% of the animals are infected with mange, and it's not having any impact on their population growth. And then all I'm going to say, I'm not going to go into those data points, except each one of those points represents a year. That is the relationship between mange deaths and other kinds of deaths, such as roadkill or getting hit by cars. We were simply looking at these to see if there's any kind of linear pattern, and that would identify whether there's any compensation taking place between mortality factors. Those graphs all show that there's no relationship, so there's no compensation between different mortality. So that also doesn't help explain what could be controlling coyote numbers. And the only reason why I have that slide up there is every one of those points represents a year of data. And we could only look at this and explore this question unless, because we have a multi-year study. So a lot of times people ask, why didn't you answer all, why are you studying coyotes for 17 years? Why didn't you answer all your questions in the first couple of years? Well, these are some of the reasons why. And then finally, so I'll just touch on this real quick. The ecological role, again, I said that a lot of people assume that we're only studying coyotes. Our research program, my research program, also focuses on every one of those other species. We've done some massive studies of skunks, raccoons, feral cats, and now we're looking at white-tailed deer and the relationship between coyotes and these different animals. And I'm not going to go through all of these, but I'm going to show you a couple quick examples. So these are the predators. So raccoons, these are the studies that we did. So we did an 8-year study of raccoons and a 7-year study of raccoons in the same area with our coyotes. Same thing with our skunks, gray foxes, and feral cats. These are truly feral cats. These are always outdoor, unowned cats. And all I want to say is that the predation percentage that you see there, that refers to the number of animals that were actually killed by coyotes. The N refers to the sample size. That's how many animals we had radio-collared. So we had 127 feral cats radio-collared, and only 7% were killed by coyotes. And those were cats living inside coyote territories. But that last column, avoidance, that's the reason why it's only 7%, is that we showed that feral cats they understand where the coyotes are spending most of their time, so they avoid those areas. So there's really strong avoidance. And that actually keeps that percentage down really low, because coyotes will kill them, but they don't go out of their way, they're not hunting them. It's only an incidental thing. This is what it looks like, so that you notice the skunk, we had 0 predation on skunks. So skunks are dominant over coyotes. And so this is that critter cam, and this is a coyote coming up to a skunk den. So you'll notice, and this is what's going to be this happens every single time. If a coyote actually tests a skunk, you'll see the response. So it's very tentatively, approaching this hole in the ground. You can see it's very careful. And then if you look really close, the hole in the ground is toward the top middle of the screen. You're going to see the head of the skunk pop out. You have to watch carefully because it's only going to be for a second. So you can see the foot of the animal is pointing directly toward that den. You see the coyote doesn't quite know what to do. It's going to happen. So watch. There, you can just see the head at the, there it was. Now watch.
Don't turn around.
I noticed you didn't have any squirrels, because I've seen a coyote take down a squirrel.
Yeah, we do have squirrels. In fact, we have a critter cam of a coyote eating a squirrel.
Okay.
Yep. Yeah, we did have squirrels on the slide.
Oh, you did? I missed
Yeah,
it.
yeah.
Okay, I'm sorry.
Yep.
Yeah.
So feral cats, like I mentioned, the few that were killed, this is what it looks like. In case you're curious, some people see that and because it's such a surgical cut, they assume that maybe humans were doing that, but it's actually coyotes.
Wow.
And then the other thing that we saw, Canada geese, as you know, are an issue in urban areas because they don't have predators until coyotes moved in. And so this was part of a combination with a large Canada goose study, also conducted by McGraw. We noticed that coyotes were moving in, they would forage, and they would go into a wetland area and come out with a white thing in their mouth. And we thought, well, maybe they were having an impact on geese through nest predation. So we monitored nests. Over 2,000 nests were monitored. This is early in our study, and they actually radio collared over 200 adult geese. There's very little predation on adult geese unless they try to defend their nest. So when if a goose tries to defend its nest from a coyote, it's going to get killed. And then we put video cameras and some other techniques on 200 nests to actually identify coyotes doing this. So this is Bessie Woods, and you'll notice some of them are in the forest preserve, some of them are actually Woodfield Mall. So we found that 50% or over 50% of the nests were taken by predators,